Okay, so in this video we're going to cover how to solve basic logarithms. So for our first example, log base 3, 9, this is essentially asking you what do you need to raise 3, or what power does 3 need to be raised to in order to achieve 9? So essentially you can put A for answer, and then you can rewrite it in its exponential form. So you write it back as 3 to the power of your answer will equal 9. So 3a equals 9. And what you want to do from this point is you want to get the same bases, because when each of them have the same base, their exponents equal each other. So if you can change 9 to 3 to the power of 2, so it's going to be 3a is equal to 3 to the power of 2. Since 3 squared equals 9, then your answer is going to be 2. And then you can use this sort of little application rewrite for all these equations. So you can always think about it in sort of a clockwise direction. This can come back to here, so 3 to the power of a will equal 9. So let's try it on this one. So equal to answer, 2 to the power of a will equal 32. And if we change the base to a 2, it's going to be 2a is equal to 2 to the power of 5, and your answer is going to be 5. And then here's where it gets somewhat tricky, kind of confuses some people. Same thing, 4 to the power of a is going to be equal to 1/4. And remember that this 4 right here has a 1 power, because anything to the first power is itself essentially, and you want to find it as just 4 without a fraction. So you're just going to flip the fraction, so it's going to be 4a is equal to 4 to the negative 1. So your answer is going to be negative 1 for that one. And then you use the same application on this problem right here. So equals to a, 6 to the power of a equals 1 over 36. So 6 to the power of a, 1 over 36. And this 36 it technically has a 1, but you want to change the base. So you can rewrite it as 6 to the power of a is equal to 1 over 6 to the power of 2, since 6 squared is equal to 36. And then you can rewrite it as 6a. Remember, if you flip the fraction, the exponent's going to be negative. So it's going to be 6 to the power of negative 2. And your answer is going to be negative 2. And then for the square root, you essentially just have to remember square root rules. So 2 to the power of a is equal to the square root of 2. And if you remember, the square root in exponential form is basically 1/2. So it's going to be 2a is equal to 2 to the power of 1/2. So your answer is going to be 1/2. And then here, this is a little bit different. It's kind of the same thing, but it's a little different. Power of a, so 27 to the power of your answer is going to be equal to 3. So in this case scenario, you're just going to have to use a little bit of algebra. So you change the base on this one because you want to have a common base. So this is going to be, or you can rewrite it as 3 to the power of 3 squared, 3 times a is going to be equal to 3. And technically this 3 has a 1 to it, because remember, anything to the power of 1 is itself. So then, since they have common bases, you can set this equal to each other, and then you can solve it. So it's going to be 3a is equal to 1. Then you divide both sides by 3, because you want to get a by itself. And your answer is going to be equal to 1/3. Because remember, again, fractions, if you were to apply this fraction, if it was a power, So essentially it would look like this. Then your answer would be 3 because it's 27 to the cubed root. They're the same thing, they're just written a little differently. And now for natural logs. The same exact rules apply, except you need to remember that for a natural log, your base is always e. I like to rewrite it sometimes, it helps me remember. So then e to the power of your answer is going to be equal to the cubed root of e. And now you're going to rewrite e into its fractional form. So e to the power of a is going to be equal to e to the power of 1/3. Because remember, the cubed root is 1/3. So then your answer is going to be 1/3. And then again on this one, e to the power of a equals e to the 4. And this one was easy, it's just a equals 4. And then for this last one, e to the power of a is going to be equal to 1/e. And then again, since remember it has a 1 right here, and then you're going to want to flip it because it becomes it'll become a negative. So then e to the power of a is going to be equal to e to the -1. So a is -1. And that's your answer for that one. Sorry if you couldn't see that. 3 rules to always keep in mind. If you get an equation that looks like any of these 3, they're basically just certain rules that you have to memorize. So 4, what raises 4, or what power do you need to raise 4 to equal 1? Anything raised to the 0 power will equal 1. So 4 to the power of 0 is going to equal 1, and that's regardless of whatever number it is. So it can be 200 to the power of 0, and it's still going to equal 1. So essentially your answer for this is just 1. A equals 1. And it's more or less just something you have to memorize. And then for log 4, 0, if you ever get something where the answer is 0 and it's a log, it's just going to be, there's no solution. Because there's nothing that 4 can be raised to equal 0. It can be all positive numbers, it can be all negative numbers, but there's no way it can equal 0. And then for log 4, -1, it's the same thing. It just can't equal a negative number. And they're just kind of some rules you have to remember about logarithms. So I hope this video was helpful. If you have any comments or questions, just leave them in the comment section below or message me, and thank you for watching.